Hey friends, welcome back in another video of ensemble technique. So in this video we will see the analysis on the marketing sales, in which we will be covering decision tree, random forest, bagging, boosting, stacking. Right, before moving forward to the objective, I'll slightly give the introduction to all these. So basically we have seen so far how decision trees work, right? And next, here you can see we have is the random forest. So random forest is nothing but one of the bagging method, where each tree is built from a sample drawn with replacement from the training set. It uses a random subset of forest instead of the feature, and find the best split among them. And here the bagging that we just heard, that which is bagging method, the random forest. So bagging is nothing but also known as bootstrap aggregation, right? That uses sampling with replacement to generate multiple samples of given size to build an like ensemble of models that improve performance and accuracy. Where the boosting methods, we have, these are based on estimators that are built sequentially, and one tries to reduce the bias of the combined estimators. So the motivation is to combine several weak models to produce a powerful ensemble, right? For example, ADA boosting, gradient tree boosting, so on and so forth. And the last one we have is here, that is stacking. So stacking is nothing but it uses a meta learning algorithm to learn how to best combine the predictions from two or more base machine learning algorithms, right? So yeah, we will see all these concepts inside this video. So basically the object of this project or this analysis is to predict sales on a given day in Roseman stores using the given features. So we have mentioned the data description here. So we will use decision tree, random forest, bagging, boosting and stacking here. So the data set that we'll be using contains features like store, where unique ID for each store, day of week or day of week, of course, date is there, sales, customer, open, that indicates whether the store was open or closed. So 01 value will be there. Promo is there, state holiday and school holiday, right? So let's start with our steps. So the first step is to import necessary libraries. So we are using import warnings, warning dot filter warning, ignore, then import numpy as np, right? Import our regular expression, import pandas as pd, scipy or stats, then import matplot lib.pyplot as plt, then sns seaborn, then factorial as f from math. We are importing train test split from model selection. We are importing multinomial naive Bayes from naive Bayes. We are importing k neighbors classifier from neighbors, svc from sbm. We are using matrix for R2 score, mean absolute error, mean squared error. We are using font manager for font properties. We are using trees, of course, for decision tree regressor. We are using ensemble for random forest regressor or ADA boost regressor. We are using tree processing for min max scaler. We are using linear model for linear regression, and we are using regressor again for stacking regressor. Now second step, it is asking that load the training data and display a sample of 5 rows of the data frame. So again we will we have done it in our Google Colab. So just mount your Google Drive like this. Then we are importing our trained CSV, which I'll provide the link in the description as well, so you can do it the same as it has done. And if you are working locally, so just skip this step, provide your path of your CSV and start it from here. Now we are getting different 5 samples. So here you can see how our data set looks like: store, day of week, date, sales, customers, open, promo, state holiday, school holiday. Third is check the shape of data, number of rows and columns. Check the general information about the data frame using .info method, right? Define basic information df, checking basic information and shape about the data frame. print shape of the data set, df dot shape, print asterisk 30 times, print df dot info, right, basic info df. Okay, so there are around 1 million instances and 9 features. There seems to be no null values. State holiday is of type object, but in the above sample we can see that there are also numeric values. We will have to check these columns and fix it. Date column is like the index for our data set. We will drop this feature, but we can try to create new features from it. Check the percentage of missing values in each column of the data frame. Drop the missing values if there are any. Now df defining check missing values df function to check the missing data percentage. Print percentage of missing data of data frame. Df dot is null dot sum divided by length df multiplied by 100. Check missing values, that is df. So as we earlier, there are no null values, right? You can see that. So now the fifth step is check if there are any duplicates rows. So defining check duplicates df, duplicates equals to df of df dot duplicated, and then return duplicate, right? Duplicate equals to check duplicate df, and duplicate is printing. So here you can see that there are no duplicates values as well. Sixth step, it is asking that check and convert the column state holiday to numeric. So df state holiday dot unique. So array 0 a b c 0 d type equals to object. We can treat the holiday as ordinal data. For example, categorizing holiday by popularity. As no holiday is already 0, we can set public holiday a equals to 1, Easter b equals to 2, and Christmas c equals to 3. df state holiday dot value counts. So here you can see for 0 0 abc, these are the values. Holiday map 0 for we are labeling it like 0 for 0, a for 1, b for 2, c for 3, and again if there are any 0, that means none, so non-string, so again for that is 0. Now state holiday df of state holiday dot map holiday map, df state holiday dot unique. We are using the unique function here. Create a new features recency from the date column, where recency number of days between the end date and the current date. Also drop the column date and store. Df date equals to pd dot to date time df date, right? Print df of date dot max. So here we are getting the date here, the maximum date here, right? End date, we will get the df dot date max. So we are defining the end date here. The maximum date is as our end date. Df dot recency, so df dot date dot apply lambda into end date minus x, right, and dot days. So what it will return, it will return the 5 sample based on this date. So you can see that these are the sample that we are getting, that recency and the values. Now df dot drop labels, so we are dropping date and store access 1, that will delete the columns, and in place true, that means permanently deleting. Sample of 5, so here you can see that day of week, sales, customer, open promo, state holiday, school holiday, and recency. Now 8th is checking the basic statistics of the data frame using describe method. So here defining basic statistics df, returning df dot describe dot transpose, right? So it will return all the attribute with respect to our describe or statistics. So count, mean, standard deviation, minimum, 25th percentile or the interquartile ranges, and maximum. Now the observation, we can see that the store columns contain store id, right, which we are not interested. So we will store we will drop the column, that is id. Features like sales, the customers seems to be right skewed with the presence of outliers, so recency seems to be normally distributed. Features like open promo, state holiday, school holiday contain binaries values. Now visualize the distribution of data in column sales, customers, and recency. So sns.distplot df.sales. So here you can see that the sales and density here. Now sales is 0 for a lot of days. These must be the days when the store was closed, holidays, right? Also there seems to be huge outliers. So here you can see that. Now sns.distplot df customers. So here the customer we have and the density with respect to it. Here also we see a similar distribution, so the distribution as this is. Now we are plotting distplot for recency. So here you can see that the recency data is basically uniformly distributed, right? So here you can see that the uniform distribution. And plot box plot to visualize the outlier in the column sales and customer. So also check if having a promo offer has effect on sales. So here you can see that the box plot we are defining. So box plot y equals to sales x df dot promo df equals to data equals to df. Now we can clearly see that sales are higher for the days when stores have a promotional offer. So length df, right? Sales is greater than 20,000 divided by length df, right? So here you can see that only 0.4% of the data have sales more than 20,000. We can remove these instances later after analyzing the data. Now 11th is let's visualize if day of week have any effect on sales. So this is sns.boxplot y equals to sales, x equals to df dot day of week, and data equals to df. So here you can see the box plots. Now 12th is let's visualize if state holiday have any effect on sales. So sns dot scatter plot x equals to customer, y equals to sales, u equals to state holiday, data equals to df. So we can see more popular holiday have higher sales. Now let's remove the instances having outlier in sale columns, drop the instances having sales greater than 20,000, right? So what we'll do is we will redefine the df and we will take sales where the values are greater than 20,000. Now handle the outliers in customers column. So sns.boxplot df customers. So the box plot you can see here, length df customers greater than 2500 divided by length df, right? So it is giving us 0.0050 of accuracy. Df equals to df customers less than 2500. And 15th is now it is asking check the correlation among features. So plt dot figure fixed size equals to 96, sns dot heat map df dot correlations, right? And annotate equals to true. So here you can see that the feature we can say the recency which we created does not have any high correlation with sales, right? So you can see that even the highest seems like the darkest one, that is looking like open, or the state holiday that are open, right? So yeah, again the feature recency which we created does not have a high correlation with sales exactly. Now next thing or the next part comes is the model building and evaluation. So first thing is storing the target column, that is response, in the y variable and the rest of the column in the x variable. So y equals to df of sales, x equals to df dot drop sales, right? Xs equals to 1. So split the data set into two parts, 70% train and 30% test using random state 42. X train x test, y train y test, train test split, right? Xy we are passing, test size is 30%, that means train size will be 70%. Random state we are providing an integer as 42. Train a decision tree model. So dt equals to decision tree regressor, dt dot fit function we are calling for x train y train. Y test prediction equals to dt dot predict x test, y train prediction equals to dt dot predict x train. Now printing train r2 score of y train prediction, print test r2 score of y test prediction, right? So the train accuracy that we got here is 97% and the test accuracy we got here is 78%, right? So yeah, here it was. So we can see that the model is overfitted. Let's try to prune it out now, right? Because let's try to prune it out, right? Now train multiple decision tree models with different values of maximum depth and maximum features. So we are defining maximum depth as 357, maximum feature is again 357. For I in maximum depth, for j in maximum feature, dt equals to decision tree regressor, maximum depth equals to I, maximum features equal to j. Dt dot fit xtrain ytrain ytest prediction dt dot predict xtest. Now ytrain predict equals to dt dot predict xtrain, printing train r2 score with maximum depth I, maximum feature j, r2 score ytrain prediction, print test r2 score with maximum depth I, maximum feature j, r2 score of y test and y test prediction, and printing the minus 20 time, or the hyphen we can say. So with each iteration you can see that the train r2 score with maximum depth of 3, then we get the maximum feature 3 is 0.77%, right? r2 score with maximum depth 3, maximum feature of 3, 77%. Similarly r2 score with maximum depth 3, maximum feature 5, so here you got 81%, right? r2 score with maximum depth 3, maximum feature 7, 0.81%, so on so forth we got with 357, right? Now we can see we are getting the best r2 score using max depth 7. Here you should notice that when the max depth is 7 and even the max feature is also 7, then we are getting the best score, that is 87%, right? And for the train and test both. Now fifth is, it is asking checking the importance of feature as per the decision tree. So pd dot series dt dot features importance, right? Index equals to xtrain column. So here you can see day of week, we have customers, open, promo, state holiday, so on so forth. Now customers and promo, right? You can see that found the best feature 9.63 and 2.87. even the day of week as well, it is 8.00. (987). Now sixth is train a random forest model. So yeah, how can we do that? So defining a variable rf, we are passing a random forest regressor, right? And the function is getting called rf.fit xtrain ytrain, ytest prediction equals to rf.predict xtest, ytrain prediction equals to rf.predict xtrain. Now printing train r2 score, okay, r2 score ytrain prediction, and printing test r2 score ytest prediction. So train r2 score 0.96% and test r2 score we are getting 0.85%. Here also we can use the model is a bit overfitted, so printing rf. So here you can see random forest regressor we are getting called, and bootstrap or all the other values we are passing. Later you can try to fix the random forest model using different sets of hyperparameter. Now train in ADA boosting or ADA boost regression model. So ADA equals to ADA boost regressor, base estimator equals to dt, random state 7, learning rate equals to 0.1, ADA dot fit equals to xtrain ytrain, ytest prediction ADA dot predict xtest, ytrain prediction ADA dot predict xtrain. Now print ADA. So here you can see that we are getting that decision tree regressor or our ADA boost regressor here. So these are the values: CP alpha 0.0, criterion MSE, max depth, so on so forth, or all the parameters that ADA boost regressor is returning. Now printing train r2 score ytrain prediction, printing test r2 score ytest prediction. Train r2 score we are getting 87%. Similarly test r2 score we are slightly getting 87%. Now there is no significant improvement, but we can try different base estimator, maybe more simple models, and try with no other set of hyperparameters. So let's train a stacking regression model. So SR that we are defining is a stacking regressor. Regressor equals to linear regression, right? Decision tree regressor, maximum depth we are passing 7. ADA boost regressor, we are the function that is getting called. Now meta regressor, we are saying that okay, random forest regressor, and passing the n estimator as 30. If we print that SR or our stacking regressor, so here you can see that the model that we have got here. Now if we do the sr dot fit xtrain ytrain in our train test data, train test data, and s test y test prediction is sr dot predict x test, and y train prediction sr dot predict x train. Now printing train r2 score of y train prediction, printing test r2 score of y test and y test prediction. Train r2 score 0.95% and test r2 score is again 0.83. so here this model also seem to be overfitted, right? So 95% we are getting for train, 83% you are getting for a test. So if we conclude this, the data set seem to be prone to overfit, right, and thus performed well on simpler model. So you can test with your own data set as well, or the technique, because here we have tried to tell you that how you can use all these AI algorithms and functions in your existing data. So you can analyze with your own data, right? You can get the predictions and you can conclude it from there as well. So yeah friends, this was all about this video. Thanks a lot for being with us. We'll come up with more interesting videos. Have a good time.